Hey, hello. Welcome to the Legend of Data. It's the second episode. It's the second week that we are doing this. So last week we actually install the Jupyter Notebook environment. And let me fix my chair. It's actually a very comfy chair, but the cushion I need to adjust them. Yeah. So and if you're new to my tutorial series, so usually I would have the slides publicly available. But I think for this series, I think some what would be more useful would be my Jupyter Notebook, because I just realized that actually it's like it would be much more easier to just like do everything on a Jupyter Notebook. So instead of my other tutorial that I do on Sundays or yesterday, that I have to switch between slides and my IDE, and sometimes I forgot, which is a disaster because you'll be looking at nothing. Um, so yeah, and oh, by the way, and also welcome to just shout at me at the chat if I did that, or if you have any questions, give me a shout in the chat. In case you don't know, I have a laptop with me that is actually monitoring what you are seeing. So if you type in the chat, I actually can see it. There may be some delay, but I'm monitoring it, so I will see it, even though I don't put it on the screen. But I'm watching the chat. Um, so yeah, this series, I think last week I've covered that a little bit. That we are going to go through a lot of stuff that the data scientists would use in the job. Most of them will be like in Python, and it will be open source, so it will be like a free software for you to use. And maybe I would just give you a brief introduction of who I am and why am I doing this, because like this is new series. I am expecting a lot of new people that doesn't know me, and who is this crazy crazy person that is giving all these free workshops. So yeah, I'm Chuck, and you may see my banner already. That actually I love contributing to open source. I have tried, I have worked on a lot of open source project before. Uh, one of them is Terminus DB. You can see the little cow there. That's our mascot. So I work full time now for Terminus DB, and it's an open source graph database, so it's still related to data. But before that, I was working as a data scientist. So I always have these my favorite thing is still talking about these tools that are used by data scientists, because like I have a thing about the open source tools. That's why I decided to switch from a data scientist to work on an open source tool, which I think is a dream come true. I can do this, and I'm really happy that I'm doing this. I'm mainly working on the Python client of Terminus DB. We have a wonderful team. My teammate is working on the architecture, the back end and all the beautiful console and other components of Terminus DB, which is amazing. Like, check it out if you want to. Um, and also, I organize a lot of a lot of things for the community. I'm just like, sometimes I feel bad because I have to do this, do that, and I sometimes I'm sorry if I have something lingering for a little bit longer because I have a lot of things to do. One of the things I love organizing is the sprints. So what is a sprint? Sprints usually is come with a conference that let people contribute to open source. Sometimes we try to organize it like a meetup, so people regularly contribute. So it's not just when you go to a conference you got a chance to learn stuff by doing stuff, by giving back to the community, but at the same time you learn so many stuff. Like, I've contributed to Pandas before, so that's what we're talking about today, and I learned so much. Like, even though my contribution is very little, everybody can do it, but actually like give you a very very good chance to learn. So if you're learning, I totally recommend to try out in some of the sprints. So a lot of the sprints are actually beginners friendly. So there will be like mentors there, and the maintainers usually like they're super happy to teach you. So that's great. You can learn a lot of really really like advanced stuff from senior people. So okay, all of that out of the window, and then and then today we're going to talk about pandas. So panda is one of my favorite things. Not just like the animal is cute, but pandas, the data science tool that is, well, I grabbed the introduction from the official website, pandas.pydata.org. That's very useful for you. because I always have my documentation at hand when I'm working with Pandas, because you will know why. Like when I show you the actual documentation, there's so many things in Pandas that you can't remember everything. Like if you're a more experienced user like me, I've been working with it for years now, and I would give you like, oh, I want to do this, how can I do that? And then if you ask me, I would have an idea what you should look at, what approaches you should do, but still for the details, like what parameters you should put in, like what arguments and all this, like what's the input and all this stuff, I still have to look it up, sometimes, because it's just like it's not just like a switch army knife. It's like it's your whole toolbox, so it got everything that you need. So there's so many things that sometimes if you haven't used it for quite a while, you have to check the documentation. It's just like me. um so yeah, in a short description here, like this is the one below is in my own word. Okay. Yeah, it's like let you read and write data from CSV, Excel, and handle it in a tabular format very easily in Python. You can even manipulate them, change the data type, join them together, aggregate them, do some, calculations. There are lots of stuff you can do with it, and I I think, I hope that in this series I would cover as much as I could, and but I always, I would forget about some little stuff that, maybe you encounter them at your work, or if you want to know more, let me know, because well, I'm just like when I think about that, I may overlook stuff. I may mistake sometimes, or actually a lot of times. So yeah, so this is what we're gonna talk about. So I actually have the plan in my mind, okay? I have it in my mind. So um, what we're gonna do is that first of all, today we're gonna cover all these topics. So there's so many things. Is installing and checking, you know, whether we have the pandas installed. So last week I teach you all that if you don't have anything yet, if you only want to use Python for data science, the best package you could get is to download the distribution from Anaconda, and that's they would have all these stuff, like 90, I would say 99% of the stuff that we're going to talk about in this series already bundled in. So when you install Anaconda, you will have Python, you will have everything that Jupyter Notebook and all this, like all this stuff that we got to Pandas, all this stuff that we got to talk about. So it was super convenient for you. But personally, because I already installed Python for my work and other stuff, so I have my own environment. I don't want to install Anaconda because they use a separate package manager called Conda that sometimes, when I have both of the Conda environment and my own PyEnv environment, they don't like each other. They'll be like, it's like yeah, like your partner, they just want to be the one, you can't have the second one. So yeah, and then I decided to, okay, well, I have to of course have my original environment for work, so I would just install it, every episode I would just install it there, so you know how I install it. And I'll also put all of them in the requirements.txt file, so if you come across this like much later, you want to install everything in one go, you can do that. I will show you in a bit. I'll show you, actually the first thing that I'm gonna show you is this, and I gotta tell you how to read and write from CSV. I may talk about Excels, but they are usually quite dirty. I would explain again why as well, because Excel sometimes it doesn't like to be manipulated that way. So but CSV is totally fine. It's the standard way of loading a local file and exporting a local file for data centers. So that's fine. Actually, there's other stuff you can do with that. You can also, for example, you have JSON file, you can totally like, load it in with pandas as well. And you have other files that, that is also, when I show you the documentation, there's other formats would also be supported. Another way to do it is to load it from a CSV, SQL. So if you have let's say you're using Oracle's database, let's say using or you're using, like, let's say MySQL, then you could have a driver, and you could use SQL Alchemy to hook it up. So you could use Pandas and directly put in a SQL query, and then it would give you back the result, and you can store it as a data frame. And also, what I'm actually now doing very crazily is is because like I told you before, that work for Terminus DB, and we are building the Python client. So we are also having this functionality as a new functionality that you can also get the result from Terminus DB, and it will be stored as a data frame as well. So yay! Well, but it's not in Pandas, so it's not official, but we kind of like third-party thing. But you can also do that. Well, so there's a lot of possibilities because Panda is so popular that everybody wants to be able to talk with it. So yeah. Okay, head and tail. Well, if you used command line before, the head and tail command, at least in Unix, I don't know about Windows, but head and tails actually is like giving you the beginning of a file and the end of the file for you to preview it. So you can do that in Pandas data frame as well. And also, I'll talk about how to slice things. And also, but before that, sorry, I skipped that. Before that, we got to talk about what's inside a data frame, like, and what is a series, all this stuff. I think that's something that a lot of beginners tutorial don't talk about, but I think it's very, very useful that you know a little bit about how pandas is structured, how the data frame is structured. Then it's actually help you to understand a lot of the operations that we're going to cover in the tutorial. That I always think that if you understand a little bit, at least like the theory of how things work, then it's easier for you to remember how to do stuff, or have a good idea of how to solve your problem with pandas, because you understand how it works. You know that what works, what doesn't work, which approach to use to get your thing done. So I found that very useful, and I would try to teach you a little bit about that. Of course, you can always read more documentations if you want to know more, but I will try to cover all the things that you know, or like at least most of the things that you know. Okay, so yeah, and after that, we'll do the slicing and play around with the columns and indexes, and try to do some manipulation already with the data, because we know the internals. We can try to dissect it, and other thing we could do is to change the data type of the data frame, because we will cover that, like, because in pandas, they store things in, when we cover the internals, you will understand why. Because like they store things in blocks, and then each block got a data type. So if you want to convert them, you have to do it by having some commands to change the data types. For the next tutorial, which is next week, um, if nothing happened, unless I broke my leg, but I won't. Yeah. So I would talking about apply. So apply is to sometimes it's useful if you're on the go through. Well, this is not recommended because it's quite slow, but sometimes you have to go through your data frame row by row and do some manipulations. That's when you use apply, okay? And also, so that's more advanced topic, right? And also we talk about some aggregation operations. And actually, I think that I'm missing something here. Maybe I'll cover it like next week. I will refine what's going to be next week better before today and next week. So yeah, we're going to cover apply. We're going to cover aggregation operations, which is like, for example, if you want to calculate the sum of everything column wise, then how do you do that? Just try to get a summary of things, all these aggregation related operations, and then we can do a group by. So group by is, well, group by and actually joining is something that you do a lot in your work if you're a data scientist, okay? Because a lot of time you just can't use the data as it is. Like, you still have to if it's a lot of things, you may want to, if you, before you input it to your model, you want to group by, and use different tactics to train your data. So group by is very useful, and also group by is a topic that it needs some explanation, because in pandas, after you do a group by, actually it will give you a group per object. And there's a lot of things you can do with it, and not just group by, maybe give me a sum, or like group by and give me the count or something. Like, you can do that as well, that's easy. But if you want to do more like custom stuff, do more like more complex calculation with the groups, then how to do that, I gotta spend quite a lot of time talking about that. Joining is another trick, because most of the time after group buy, you may want to join things back together, and joining also takes like there's a lot of little things that may ruin your joining. So that's why I think it's worth covering like next week when we got more solid about what is pandas, and spend more time in tackling those. So I think this is more or less for this slide. Like for my slide deck is nothing there, like because in this series the most important thing is the the Jupyter Notebook. Okay, this is too small. Let me make it bigger. And yep, I hope this is big enough for you now. If it doesn't, like give me a shout in the chat if it's still too small, okay? I think this is big enough. So yeah, I have to sip my green tea. I love green tea so much. I bought so much green tea recently and try to be healthy, so that's why. Okay, so so you can see that now I got something in my Jupyter Notebook. I would actually upload this. I forgot because like I was working the whole day and I forgot to do that. I would push this folder. This I would make it a GitHub repo. I'll push it in my GitHub, my GitHub channel. I think I forgot to put it in my first slides. Is actually it's just my username is just Cheukting, CHEUKTING. So I'll also put the link in the description below. So post editing, yay. So I would or I would maybe put it here, in I don't know. I just like put it somewhere so you can find it in the post production. But yeah, so I would upload this as well after I'm done with it, and like I mean done with it. I mean by the end of this streaming, I hope it's done. I'll upload this, and so you can get all of these and play around yourself. And this one would be the repo that I keep all the stuff that I do in this series there. So you would have it. So this is the requirements. The text I talk about now is empty. I would actually put something in when I do this. So okay, so this is the Jupyter Notebook that I created. So if you go back to my directory, you see this is what I created. So this is everything that we have today. And we have this Pokemon.csv. So this is a CSV that again I forgot to put the source of it is somewhere on GitHub. I found it, and this information about Pokemon is a Creative Commons thing, so it's totally open data. I'm not stealing some. Well, I have to reference the author who organized those knowledge and put it in a CSV. But this knowledge is not something that I stole. So this is Creative Commons knowledge. Actually, you can find it on Wikipedia. So don't sue me and don't try to sue me. Okay. So right, because you have to be very, very careful when you handle with data because, of course, sensitive data you can't disclose, and sometimes, if there's not a public data, you can't use it in your work. So you have to be very careful with that for the new data scientists or people who want to be data scientists. So there's some kind of like a industrial golden rule you have to follow. Okay. So first of all, we have the install. So I have no pandas here. So if I can actually show you what I have. So this is, remember we talked about Jupyter Notebook last time. So if you type a exclamation mark in front, this is you can run this as is a command line. So if I do this, actually it should call pip and show me what I have. Actually, I got quite a lot of stuff already, and I have pandas already. What? I was hoping that I could show you, but I think I accidentally installed it, or maybe why is the case. I don't know. Maybe last time I installed it and I forgot about it. I'm so stupid. But anyway, we know that we have pandas, so we don't have to. But if you want to install pandas, you just pip install pandas. But this is not a good practice. What is a good practice? For example, you see I have a typo. I'll install something wrong, and well, if you're lucky, it will just give you an error, pip saying like, oh, I can't find this thing, right? So, but if you're unlucky, someone maybe like take advantage of people like me that is very careless with my typing, and put a library that name like pandas, like without the a, so it's not pandas, and hope people like me would accidentally download it and they put a malware inside so they can steal all my information when I install it. So don't do that. Usually what I'm going to do is a little bit, well, it looks stupid, but actually I don't think it's stupid. So what you got to do is that you want to go to the official documentation of pandas. So how do you know it's official? Well, the easiest way is to Google it. So if you type pandas, I don't know if you can see it, but Yeah, Pandas. Yeah, PAN. You still spell it wrong, but Google usually will correct you. So Pandas, you can type Python. So now I don't type an S here, right? So you can see that I don't type an S here. I spell it wrong, but you will see that I still got the first result is still the official documentation of Pandas. If you type Python with the name of the library that you want to install in Google, usually even if you made a spelling mistake, it will show you to the correct one. I would say 99% of the time. So okay, so this is the official documentation. And how do you know? Well, because Google suggested it, I think you have to trust it, or because I know Pandas is supported by PyData and Unfocus, so I know that this looks very legit to me, and so yeah, it's also said that it's supported, so and install Pandas now. So click on it and see what it's saying, and it will teach you like, of course, the safest way is to use Anaconda, but I'm teaching you how to not use Anaconda but still be a little bit safer. Is to go to our official documentation website and look at it, and it's not saying how to pip install. Why? It's super strange. Maybe let me go to their actual documentation, they will show it. So usually it would be like showing me how to pip install stuff or something. Yeah, this is actually, by the way, is the new website. It was not like this when I start to use Pandas. It was just like a old Read the Docs template. So Read the Doc is a famous website for people who created Python packages to upload their documentation there. So it was a standard thing, like a very but this is custom made. This is I'm very impressed. So I prefer pip. So we gotta copy this. So even though you can totally type this yourself, right? But just to be sure that you didn't make any typo. So this documentation, at least like there will be for Pandas, there will be at least 1,000 people use it before you. So if there's a mistake, I hope that someone already reported it. So go back to this, and you can paste it here, so it won't be a wrong thing. So if you pip install it, it should install. But since I already have it, so it says that I already have it. And so this is how you install Pandas, okay? And what I gotta do is that I gotta actually put this in the requirements.tag, so you have it. And also, what I gotta do is that I want to pin the version as well, because if someone come, like, if someone come to my repo years later, they may actually like want to use the same version, so this tutorial still works. So what I gotta do, yeah, my pip is old, you see. But what I gotta do is I want to see the version of my pandas. How can I do that? Okay, so right, if you want to use pandas in this Jupyter Notebook, so you have to import it. So import pandas as PD. So you can just import pandas without using the aliases as, or you can import panda as. Um, oh, someone tried a pandas emoji before. Actually, I can show you that. um, yeah. Oops. Yeah, you can actually, you know, do an import pandas as panda emoji, but every time you refer to pandas, you have to get your pandas emoji. I have in my web browser, I have a plugin that let me type emoji slightly easier, but I don't think you want to do this, because every time you call like, for example, if you want to make a data frame or read a data frame, you have to type this emoji, and yeah, if you have a lot of time, do that. But I'm not going to do that. So most of the time, data scientists, their time are precious, because they are one of the higher paid people in the world, so they may not want to waste their time in their work. So they will just type PD. So it's a short for pandas in the script. So if you see that later, you see a PD dot a PD dot data frame, and PD, actually you can, if you don't do as PD, you need to type out pandas, right? So the standard is to use PD. So all data scientists understand that PD means pandas, because it's just a convention that everybody use. And so I would recommend you to stick with the convention. Uh, don't throw your colleague by changing this to, because NumPy is another famous one, and don't throw your colleague like this, right? Your colleague will totally hate you and stop talking to you for months, so or weeks. I don't know. Like maybe they're not that bad as me. Okay, so let's fix this. Okay, so yep, and it should be importing my pandas. And Pandas is quite big, so it's take quite a while to import it. And what I gotta do, oh, so last time I showed you how to add a cell below. So you can do this cell and add below. No, sorry, edit and add the cell below. And sorry, insert cell below. You see, I rarely use those. I can't remember. And usually I use the plus button. But another way to do it is to remember this is the edit mode, exit the edit mode, and then last time I remember it wrongly. So it's, instead of Command or Control B, so it's just B, right? Okay, so add one below. So okay, enter the thing to edit it, and I want to print out the version of it, so I can pin the version. So what you can do is to, I think this will work. If not, then yeah, so just give me the Pandas version, okay? Sometimes you may want to check whether your version is what it's supposed to. You may want to match your version with your colleague. So the best things to do is to have a requirements.txt that store all your libraries and the version of them. So when you pass your project around, you can pass this to your colleagues, so they will have the same thing installed. They will have same version of Pandas installed, okay? So that's what I'm gonna do here, and like I said, I will upload this so when people use this, they will know that I'm using this version of Pandas, okay? And okay, that's done with you, requirements.txt, okay, close it. You know, I have a bad habit of leaving tabs open, so which is trying to change that, okay? So, and now we have these, and so if you don't have your Pandas installed, this will give you an error already, so you know that you have to do this, okay? And I think that's it for this part. This is a short bit, and we already half an hour in. Oh my god, let's go quicker. And okay, read and write to a CSV. And so we gotta try to read this Pokemon.csv. Remember, this Pokemon is sitting in the same level as where we are. But actually, I have changed my mind, and I think that I should put this in a folder. Just code this, you know. So what I can do is that I can actually new and create a folder here, so you know how to create a folder. Oops, and no, give me back. Okay, and I want to rename it. So rename. So this is okay. Jupyter Operations for you as well. So I call this example data, or I just call them data because I'm lazy. Okay, and I want to move this into, so I can move, and I can move it into data. Thank you. And now it's in data. Okay, so Pokemon.csv is in data, and so why I'm talking about this, because this is important when you load in your data. So first of all, how to do it is to use pd.read csv. Okay, so you put your file name here. So so instead of just Pokemon.csv, you have to put the path. So it's data slash. It may be different in Windows. So usually Windows, I won't do things like that. I'll just put it in the same directory. But because I'm thinking, oh, I'm keeping this for quite a long time, maybe it's good to, you know, be more organized. So, but this will read it and assign it to, now we are assigning it to nothing, which is bad. So we need to store it. So, okay, how to store it is to we'll create a variable. So usually we just call it df, but this is bad because first of all, variables need to be more than 3 characters long in name. So this is too short, but well, data scientists love df because it's a data. It will become a data frame. So after pandas read it, it will becomes a data frame. So so what I got to do is I will call it Pokemon df. Okay, so Pokemon df. So this is more descriptive what DF it is, because you may have, you know, in one of your Jupyter Notebook, your whole project, you may have more than one data frame, or after you clean it, you want to store it as a different data frame. So yeah, you don't want to just call it DF. Lots of cases. So let's try to see if this works. Yeah, okay, it works. It doesn't give me an error, but what I'm going to do is to show you. So actually, you can just like, you know, in Jupyter Notebook, you can just type Pokemon df. Oops, sorry, df. Too fast. It will show you the whole thing. So you see that there's quite a lot of rows, 800 of them, and 13 columns. So I won't consider this is a big CSV. It's kind of like a small CSV in my opinion, because if you're working with data, usually you handle things much bigger than this. So but this is good for example. It won't take forever to do stuff, so which is good. But remember, this is kind of like a toy for you, right? To try things out, to learn things, and it's about Pokemon as well, so it's cool. So you see that from here, this is generally how it looks like. You may think that now I have 13 columns. If I have lots of columns, what should I do? Or if I want to show all of these, like what should I do? There is actually an option for you to show them, and I forgot to prepare it. I think it's display option. So, okay, now let me show you the documentation for real. So you can see that I already have it opened, and this is all the stuff. This is just part of the stuff, but you can see that there is so many things that Pandas is offering. Even the series got like loads of stuff, and DataFrame as well. So yeah, no shame of checking things. I do as well. Like now I want to check the input option, so I can go to search. I'm sorry, display option, I think is what it's called. And options and settings. Can I do that? Yeah. Or sometimes you can, yeah, here, PD the options, display. So this is the option that we have for now. So there will be a default. Is it big enough for you? Can you see that all right? I can zoom in a little bit. I hope this is better. Yeah, I hope my head is not covering too much as well. Okay. So yeah, you can actually set the option. So you can get option, but you can set the options, right? So you can set it to have a maximum of row to be 9999. So yeah, I won't change that because it will look super ugly when I come back here. Imagine this is like 999 rows that is showing. Then it's scrolling forever to get to the bottom of these 800 rows. So yeah, that's how you can, there's an option that you can change how many rows and columns you can show in a data frame. Sometimes it's useful because you want to see all the columns, and if you have too many, it will also become dot dot dot, and you want to see what's in the middle. And that's also, that's something you could do. Or you can just show all the columns and pick one that you're interested to just show that column. We will talk about that when we talk about columns, okay? So let's talk about sorry, I go like I skip ahead as well. We haven't write to CSV yet. Okay, sorry, but also I'm not done with the Read Csv. So I've linked to the documentation because, like I said, no shame of checking it, and I would recommend you check it. Why? Because Read Csv got loads of options, and I want to go through some of them with you a little bit. So sit back and buckle up because there's quite a lot to go through just for one method. But you use it quite a lot, so it's worth to go through them a little bit. So file name, that's the only thing that is required. So this is the name of or the path of your CSV. I've shown you already. SAP SCP SAP is a separator, so the default is a comma. So in our, can I show you this? In our Pokemon.csv, you can see that. So okay, what is a CSV? So CSV is a long name is comma separated. What's V? Uh, no, I don't know. So it just means that comma separated. Okay. So what is V? Oh geez, like if you know, tell me in the chat. Sorry about that. I'm bad with names, by the way. So yeah, so it's comma separated. That's what I'm trying to say. Okay, and for each different columns, it will be separated by a comma. Different row, it will be a new line. So you see, this is all of them a new line, and it will become a new row. So go back to the CSV. Yeah. So, but you may come across a hello values. Oh, comma separated values. Thank you so much. Saved my life. Yes, that's totally correct. Thank you. Okay, Kihos? Sorry, I can't pronounce your name. I'm so bad with names. Sorry. Yeah, unless you have a very generic name that, I guess. I'm so sorry. Yeah, but yeah, so sometimes like your file is not comma separated. Sometimes, I've worked in in the industry. Oh yeah, Kenneth. Hey, Kenneth. Yay. Maybe everybody should just like introduce yourself at the beginning. Okay, I would do that next time. I would ask people to introduce themselves in the chat before I started. So thank you, Kenneth, for letting me know what is V in CSV. Yeah. So but sometimes it's not comma separated values. It's pipe separated values. So what is a pipe? Pipe is just the vertical line. I don't know why people call it pipe. I think it's because can I have a cell please, like so I can show people what is a pipe? Okay, let me do this. Okay, so yeah, so this is this thing, right? So this thing, I think in command line, then you have a lot of you know like concat or something, no concat cat, or something that you do with your terminals, and then if you want to put one result into the second command, so you use this. So that's why this is called pipe, because this is piping. So a pipe separated unit is something like it will be something like I can maybe if I copy this. So I use this as an example. So it would be not a comma. It would be like people separate the data like this, and then you'll be like, okay, how can I read it into a pandas data frame? Well, you just change this. You add one. You know, SCP equals to this. Okay, so and it will work for you. It will be fine. And a more common way, like instead of this, it will be a tab. So people, can I use a tab here? I can't. Okay, maybe I can't use a tab in here. Yeah. So sometimes people separate the data with tabs, and this is horrible because well, I don't like tab personally, because when you look at it in a text editor, it's so difficult to see because some of the data is super long, then the tab doesn't align. You'll be like, what is going on? So but what you can do is to do a /t. So this is a type separated value, I guess. A file that all the data are type separated instead of comma separated. You can do this, and if it's just separated by white space, some of them are. It's like this. And yeah, I think those are the common ones. If you encounter anything funny, don't worry. You have this SAP as an option for you to use. Okay. So our default is comma, so it's fine. And so this is the same for SAP. You can use. I think this is the old name, so that's why both of them work. Okay. And header means that what will be used as a header. So for our data, it got the first line as a header, which is kind of a common thing. So if you use the default setting, it will work. So if you give nothing there, so you're using a default setting, then I believe it will take the first row as the head. But if you know don't have if you don't have anything, I have encountered that in the open flight data that I've used before, and they don't have a header. They have like they start the file start just like this. The file start with just like this, this, and how do I know what is what? And they kind of put it in a separate file, saying like, oh, the first column is this, the second column is and so you have to skip reading the header from, so you put it as 0, and then you pass a custom header there inside. Okay. I don't have time to show you everything. I'm just like quickly go through it. I hope I'm quick. I'm saying too much. And index column, same thing. Like, do you want to have an index as your column? So here, look at our thing. So now, so you can see this is funny, right? Because in our CSV, this is meant to be the index. The first thing is meant to be the index, and here, it doesn't. So because we haven't set this thing up correctly. So this index column is that so yeah, so which one do we want to use as the row label, which is the index of the data frame. So the default is none. So the default, it will create just like this 0 1 2 3 4. It just like do that for you. But I may not want to do this, and this is funny, you can see. Yeah, I have some messy data in my CSV, which is great because there will be like more things we can do in the future to clean this up and see what's going on here. But if I want to use this as an index, then I could do that. But now I wonder if I could, you know, I could set this up properly, because if the data is a bit messy, I don't know what it will become. So let me try to set this equals to 0. So it will use the first column to be the index, I think. So let me double check, because like this is the fine detail that I said it's difficult to remember everything. And the multi-index is used for sequence, so I don't have a sequence, so maybe I shouldn't have the bracket there. Otherwise, it will become a multi-index, which is more complicated. And okay, let's see. Okay, yeah. So it's now used the first column, 0. So everything starts with 0 in Python anyway. So remember, first column 0. So yeah, you use that as an index. So now it's funny. It's still 800 rows, but some of them got the same index, and it's gonna be messy. And yay, messy data, more cleaning. Yeah, that's something that you may encounter in your real use case. Okay. And what else do I have? And yeah, it's nothing important. I'm not checking that, because yeah, my phone rings, and I'm just like, in case some like emergency or something really bad happens, so I just want to double check if that's important. And use columns. So this one is like, if you have a super big file, you want to skip some columns, you can put in use calls to skip some of them. So you only put in the ones that you care about here. And yeah, prefix is that, yeah, it's not used that often. I'll just not talk about that. You can read it yourself. D type. Okay, D type is that when you read the data, for example, now, and actually, from now you can see that we have a mix of data here, right? So I do believe, because this data frame is so clean, that most of the stuff is correct. I doubt this legendary will be a boolean, but how we can check that is that we could actually do a Pokemon DF dot D type. Okay, so there's an S there because we have multiple columns, multiple types. So so if you type Pokemon DF dot D types, it will show you all the series is not callable. Ooh. Okay, so yeah, without the bracket. Sorry about that. It's actually a attribute inside the data frame, so there's no, it's not callable, so no bracket. Sorry, my bad habit. And always actually read correctly is a boolean. So you can see that there are some like integers, objects. It could be a string, it could be something else, and I will talk about that hopefully if I have time to talk about that afterwards when I do the type change thing. And yeah, they're boolean. Actually, I'm quite surprised that they read it correctly. I think because they're capitalized and it's matching the Python ones. And but sometimes you may have, let's say, if unfortunately these are all like lowercase and it doesn't come in as a boolean, so then you can actually force it to, well, I think you, in this case you can't really force it because I don't think it's smart enough to know, but it may work. But sometimes, for example, these integers, if you have an ID here, right? Now we don't have their all stacks. For example, generation, like generation would be just like a label for which generation it is. It's not supposed to be an integer. It's just like your ID. It's not an integer. It's just a bunch of digital numbers that is carries its own meaning. It doesn't mean the number 6 or 1, 2, 3, 4. So what I can do is I could specify the D type. But actually, this is quite difficult to set up because the D type need to be a dictionary. So it need to be the column and the type. So yeah, so I think you can't do some of them and don't do some of them, but I would just give it a go. And if it doesn't work, we'll just leave it to you to do it, because so. And for example, legendary, no, generation, I want to make it a string. I don't want it to be integer. Can I do that? Okay, so the column name, and I map it to the type. So the type, I want it to be a string, so it's an object, right? It's no, so all these are numpy types. So by the way, in the back of Pandas, actually it uses numpy to deal with some kind of numerical operations, and when you have a bunch of numbers. So yeah, so actually when you install Pandas, you already have numpy. So it's because it's working at the back. So let's see if I can generation. I want it to be a string. So let's see if I can just to put str or maybe object. Let's try. I'm not sure. Okay. So okay, looks the same. And yeah, so now generation become an object. So this is what you can do with your IDs if you have a numerical ID and you don't want, people to, um, to have to, all the zero will be gone. The tracing zeros will be gone, and it's bad because what happened is that when you put this in a CSV again, then you will lose all these trading zeros, and someone who pick it up needs to put it back, and that's bad. And I did it a lot when I was working as a data scientist, and really hate people do that. So don't do that. So make sure that your type is correct, so you can do that. And okay, I'm like, oh my god, I don't know how this is gonna. I may have to break this into 2 tutorials as well. It's going to be too long, I think. I know, sorry about that, but I want to give you as much information as possible because all this little thing that is helpful in your work. Okay, so I gotta skip all this and skip rows. So if sometimes you, for example, if you have a file that they have all these like stuff in the beginning that was like copyright or something like that in the front, you want to skip them, you can use skip row. Okay, so yeah, at least this exists and you can go to this documentation and read it if you have to use it. Okay, and I will skip this NA values, and I think it's something to do with NAs, but I've never used it before, so I don't think that's common. Oh, I know. So this is okay. This could be useful because when you have a when you have a data frame that oh my God, it's my delivery. They can wait. And so yeah, when you have a file that they could they could write NA in different format. They could be null. You can see like it could be null. It could be small capital. Now it could be NaN or it could be NA. And how pandas will know it's supposed to be a NA value. So you could declare it here, okay? So yeah, it could be one of these. So there's already a lot of example here. So oh no, these are the ones that okay, these are the ones that pandas will recognize. And what if like somebody put a like emoji that means that is a missing data? You can do this. They can't throw you anymore. You can just like okay, NA values is the smiling emoji, okay? Um, keep default NAs. Okay, I won't go through all of them. I think like you have to read it yourself. Otherwise, this is gonna be too long. And date parser. Oh, this may be useful. You may want to pay attention to this when you're dealing with date. I think I've used it before. That's when you're reading the data, because like uh, so now we don't have the date here. So, but if you have a date, pandas will try to no, actually, a lot of times Pandas just put it as a string. But if you set up the date parser, then maybe Pandas will be able to parse the date for you. So, well, you can do it afterwards by changing the type, which I'm trying to go through and cover at the end. But you can change it afterwards. But sometimes useful when you already convert it in the beginning, so you don't have to deal with it later. And oh yeah, chunk size and iterator. So this one is that when you have lots of data, lots of rows, you may want to read them because like your RAM, your memory, internal memory. So by the way, Python run things on RAM so it's in memory. So usually a data scientist would have at least I'm talking about least like 16 gig of RAMs. I think most of the computer has 16 gigs of RAM already in modern days. Um, but if you're dealing with a lot of data, that even this 16 gigs of RAM, or if you have a lot of things running in the background, you don't have enough RAM to handle all your data. You may have to read your data in chunks. So this iterator and chunk size are your friends. Okay, look at them if you need to. And yeah, quote characters. So this one is like when you have funny quote characters, because sometimes if you have white space in your comma separator values, you have a white space in between, usually address or something. Oh yeah, addresses will have a comma in between. So usually what happens is that they will quote a whole address in the quotation. It could be single, it could be double, so you can set it here to set like how it is quoted. Okay, so all these are for that. And escape characters, well, you don't have to use that much. And yeah, comment, I think is they said what is a comment. Yeah, like what I said before, this hash thing, maybe people use it to put copyrights and other stuff that maybe you want to, keep them as a comment. So yeah, just basically ask Pandas to skip those rows. And yeah, white spaces, yeah. What is there so many things? Yeah. Okay. So I think I've covered most of the things that I've used and I found it useful. So let's go to write CSV. Okay. So and and I could now, let's say I have, what I gotta do now is that, let's say I only want to take the first 100 of these and put it into a separate CSV. Okay. So I haven't talked about the slicing yet, but I could do it now here, so you know a little bit. So I would be like a maybe Pokemon sample would be the first 100 rows of it, okay? So, or maybe the first, first 30 rows of it. So it's a small sample. So what I would do is that I would do, well, ideally, if you're doing machine learning stuff, you should randomly picking them, but I'm not. I'm just going to take the first 30 of them, okay? So, and because otherwise I'll be like spending too much time talking about this. And so I would have Pokemon df. The easiest thing to do is to use a head, because it would just take the first however number of rows and make it into a data frame. So it will become the Pokemon sample. And now I have the Pokemon sample. I could, write it. So I could be dot to CSV and file name. It would be data and Pokemon. Oh, sorry. Okay, something happened. So let's check. So if we go back here to our data, now we have the Pokemon sample, and we have the first 30 of them here stored in a separate file. So this is how easy it is. There are also millions of options you can have in your CSV, like similar to this. You have lots of them. Let's have a look. I won't go through all of them this time. I'll just like quickly show you what you have in your options. So it's very similar. You have all this stuff as well. You can set the separator, this stuff, and yeah, header, all this stuff. Yeah, it's more or less the same. It lets you control what you're coding it with and all this stuff. And chunks as well. You can write in in chunks. And line terminator. So instead of a new line, it could be something else, because different OS. This is more like advanced stuff. And decimals, you can change it into a comma for European. Yeah, super cool, super cool. So let's have a look at the read and to CSV. So to Excel. Oops, spelling mistake. I hope you still find it. Okay, so actually there's like a read and to Excel as well. But the thing is, like, you need an Excel writer. That actually usually you need to install a driver. So that's why I don't want to demonstrate, because it could get messy, and it also changes quite a lot depending on your OS as well. And also, of course, I don't use CSV that much, so I can't find a Excel. Sorry, I don't use Excel that much, so I can't find an Excel file to show. But usually what I would say is that if you have Excel that you have to read, because your colleague gave you that, if it's just a few files, just one or two, open it with your Microsoft Excel and change, you can save it as a CSV, because sometimes, people do calculation in Excel because people love doing that. Some analysis, they love doing that, or some business people, they love doing that, you know. And when you try to read it directly to your or you have separate pages, you can do that in Python, in Pandas as well. But I think it's quite kind of complicated unless you have lots of the CSV Excel that is the format, they gotta be like very flat, like almost like your CSV. It's just like Excel. But you want to do it programmatically because they're all the same. So then you may want to use this to help you. But I would recommend if you only have 1 or 2 files that your colleague sent you, open it with Microsoft Excel and check that it's quite flat, that is totally compatible. If you only have values, you don't have crazy calculations and formulas, and save it as a CSV. And usually you got the warnings that like it will be flattened and all this stuff. And if you're happy with that, then do it in Excel. Flatten it as a CSV before you load it in the Pandas. So that's my recommendation for beginners. Don't mess with it with these to and from Excel. All you need to know is that it's doable, that you could programmatically read and well, you can write it into an Excel, but I don't know why you would want to, because it's just flat. It's a CSV. And if you send your colleague with CSV, they can still open it with an Excel. So I don't know why you want to export it as an Excel, but if you have to, you can totally do that. But you need the Excel writer, so you have to install something else to do it. So Panda itself doesn't be able to, I can't do that because of the format and all this stuff. And yeah, if you have to read from an Excel, try to flatten it first with Microsoft Excel. If you can't, well, you could totally do that, but it will be a bit messy. I've done that before, and I would say that is not, oh, it's not even here. Oh, sorry, it's Read Excel. Yeah. Yeah, so you can see that is quite complex, and sometimes all these formula doesn't carry over. I think it's just safer to just flatten it with Excel first. Okay, so I won't dive into this, and yeah, because we are already spending too much time talking about other stuff. So let's go for the meat of it, right? So I hope I can finish within half an hour for the rest of them. If don't, we'll just like push the thing a little bit like further into our next tutorial. Okay, because I'm only happy to go for an hour and a half. I think you'll be tired, and I will be tired too, and it won't be as good. So, uh, Pandas data frame and series, how does that work? So people always wonder why I can't do this calculation, why I can't do this, why my Pandas hate me. No, Pandas does not hate you. And please don't hate Pandas. It's just because maybe you kind of don't get the concept of how it works in Pandas. So this is a picture that I stole from the internet. Don't sue me. I think it's from another tutorial website. And you can see that, these for example, is a data frame like this. So you got a mix of data type here. You got some dates, you got some numbers, some strings here, NAs, such and such. And what inside is that Panda will actually, so, oh, by the way, all of this actually is called a series. So let me do a little bit thing here for you. So if I grabbed this and yeah, I grab this df again, and if I pick something out, let's say I want to get the name of all the Pokemons, right? So uh, so this so it needs to be a string. Okay, so this will actually pick out a column of the name of the Pokemon, right? So these are, so look at this. Is it's look a little bit different from this one, right? So this one is very nice. It got all these different alternating background here. It's well formatted, and well, that one looked like this one, right? So it's a bit why? Because this become a series. So yeah, so that's why it looks different, because this is how a series will look like if you print it out. And it tells you the type of the series. Well, because a series also got its own D types as well. So you can totally do that. Ask, what is this D type, please? And is O, which means an object. Okay, you can totally do that. And if you check the type of these things, it will tell you that it's a series. Okay. Oops. Yep, so it's a series. Okay. So let me show you something very funny, because like a lot of data scientists overlook this. So what if I put two what if I put two quotation here, the square brackets here? What happened? So oh, now it looks very pretty again. Oh, this index is our index from the CSV, right? So it's not it's not 799, it's like 721. So what's the difference here? What is this? So this one you get, well, you still got this, but like it's so ugly. So what happened? Well, because when you do this, actually it will return you a data frame with just one column. Okay, so type of this one is a data frame. It's not a series. Okay, so 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 to put it like in a general case. So if you have a data frame, okay, you have a data frame. If you have a square bracket, so it depends on what you put inside. If inside you put in a string, so like name, okay, it will give you a series. But if you put in a list, so uh, so what is this? So this is a list with just one element in it, and because it's a list, it will give you back a data frame, even though it got only one element in it. Of course, a data frame could have multiple, columns, so you can have multiple elements in this list that you put in here. So yeah, if you know a little bit about Python and how Python objects and all this stuff, so this is actually a operator, a internal thing called a get item. So I think, okay, this is, I'm not sure. So if I, get item. So if it doesn't work, then ignore me. I'm just being silly. Okay. Yeah. So what it's doing is that whenever you put a square bracket after a Python object, it's actually calling an internal function called getItems. So for a Pandas data frame object, the getItem function actually check your argument whether it's a list or is a string, and then according to that, it will give you a data frame or a series. So this is a funny little thing that I figured it out, and a lot of you may not know that. I just found it quite fun to show you and try to be smart, which I'm not. So yeah. So okay, so internally, all these series will be bundled together into different blocks that according to the data type. So this is how Pandas store the objects. So and also this is how you can actually so lots of stuff. So like after understanding this, then you know how things work, and you know how this work. Also a okay, let's go back to here. So what's inside this Pokemon DF? So let's be adventurous to look at it. Okay. Yeah, I'm trying to go to a very like Python, and engineering perspective to look at it. So you can see, so DIL, if you have watched my series on Sunday, then we have tried this trick a little bit already and look at this object, because this Pokemon DF, this data frame is just an object, right? So we can look at the DIL of it. So it's like what attribute it got. So it got all these like, oh, these are all column names. So that's why you can do things like, let me add one above. Okay, so that's why you can do things like a dot, let's say a tag. That's why you can get back the series of your column without using that square bracket thing, because it become an attribute in this pandas object. I think it's super cool. And so I'm now showing you how all these stuff. So if you already know a little bit of like pandas already, and I think you never think about this, right? And yeah, I think this is super fun, and that's why I want to spend some time talking about this. Bear with me. And yeah, get item, I'll show you. Actually, it's the square bracket thing. And so if you look at the Python source code, Pandas source code, which is available on GitHub, the repo is pandas dev pandas. So actually, I won't show you, but yeah, you can find it on GitHub yourself, or find it from the documentation site. They'll have a link to it. And you can see all this stuff like how a data frame object is constructed, and how like all this stuff was constructed. Of course, I can't go through all of them, but it's just good to have a peek of what's inside. Okay, so and what else what was I want to talk about before I talk about this? Let me go back to think about it. Yeah, I want to. Yeah. Oh, it should got something called a column and a index. So is it here? Column, come on, columns, COL. columns here. So columns is an attribute inside this object. So what it will give you is that it will give you another object. So this object is actually index. So this is actually a Python index object. So if I do a type here, so is a pandas. Oh, sorry about that. I think I say like pandas and Python interchangeably like a lot of times because I'm so bad with names. So yeah, you can see that this index object is a pandas object as well. And it's funny that actually a column is an index object. And well, but you see why when we do the slicing and dicing, because it works very similarly to an index. And so yeah, so a column in the pandas, is an index object. But it's good that if you why you need to care, because it lets you see what column you have in the data frame. Like I said before, you may have like 999 columns and you can't print it out all of them, so you want to see what's column name inside. You can get it like this, then you'll see of them. You can print them out, and so you could have a good look at what columns you have. Well, it's still index, but you can change it into a list so you can have a better look at it. And yep, yeah. So now you have a good look of like what columns is in here, in this data frame. Okay. So of course you have columns. You will have indexes. Okay. So let's look for it. Let's look for it. Index here. Yeah, index here. So it should be something similar, right? Yes, it is something similar, but we only got numbers. And you see that we got something very funny. This is the one that we input from the data frame. And we should have some duplicate ones, or there's something wrong with it. There must be something wrong with it. That's why the number doesn't match. And I can't see it right now, but there must be. Yeah, there's some duplicate here. Look at this one. I'm highlighting this for you. If you can see it, I hope you can see it. Yes. So 711. So 711, that is duplicated. So actually it could be duplicated for an index, because this is a custom index. Of course, when you read the data frame, if you use the default, if you do nothing, when you reach your CSV, then it will be just like 0, 1, 2, 3, 4, and then go on. It won't be duplicated, but you could duplicate it, which is good and bad, because you see there's so many duplicates here. I think because in this Pokemon example, there are like Pokemons that got multiple entries. They may change the property of this Pokemon during different games, so maybe there's more than one entry there. So okay, so this is we have a adventure inside the internal of pandas. I hope you found it interesting and know a little bit more, and now you have a better understanding of why things doesn't work or do work. What I gotta do is I just gotta remove all this so it doesn't print out everything and it's not so ugly. So you can see that it's also an index object, but this one is a integer index, so that's why it's int64 index. I think it's kind of like a subclass of index, so they're basically the same type of object, but slightly different. Okay. Yeah, so I'll leave it here for this part, and we gotta do some slicing and dicing. So let's go back to daily life use case. Let's not go too crazy into all this internal stuff. So like I showed you before, you can actually call the first few rows of the data frame to check, to have a look. So this is the Pokemon, this is how you do this. So okay, I'll just make it simple and just call dot head. See what happens. Okay, it will give you the first, not 1, not 2, not 3, but like first 5 rows for you. But now this is 1, 2, 3, 4, 5. Yes, because the index is duplicated. That's why. Yeah. Oh, I think because they changed the name of this Pokemon and changed the stat. I don't know why they are. Are they the same Pokemon? Maybe they are, but yeah, they may decided to change it. Yeah, all these stat and name. So yeah, but you have first 5 items in your data frame. Oh, by the way, this look funny because you have a name for the index. You can actually, what you can do is that you can do a reset index to push this back inside. But why would you want to do that? Yeah, so so if you use a custom index, usually it would become like this because you have a name of your original column. So you have a name for your index, so it will be like taking up some space here, and it's totally fine for now. And so yeah, what if for example, I want 30 of them like before, then I can type 30, or let's say in this case 10, so we can print them out. So you see, oh, there's already another duplicate. Why there's like Charizard X and Y, why? And also, Pokemon, in case you're not a gamer, that usually they release the game like with multiple versions at the same time. Like for example, they have the this what is the silver and gold, yeah, and the red and green and things like that. So like every single Pokemon game, if you want to play everything, you have to buy both of them. Like Nintendo is just like very good at selling the games, I guess. So yeah, so that's why like this may be the difference from there. So this slightly different, I don't know. And yeah, so this is the so you can also look at the tail. It basically works the same, but instead of the front, it show you the butt. Can I say that? Is it inappropriate? So yeah, you can show the beginning and the end. So what I realized, I should probably keep the head because I gotta upload this file. So I gotta maybe just keep it like this. Yeah, I should maybe add the explanation afterwards, so people who just read this would know what this is going on here. But yeah, but I would recommend you watch my video because I love talking to you, and I hope you like listening to me talking to you as well. I hope it's entertaining because I am a little bit like silly. And so this is head and tail. So slicing and dicing. So uh, like I said before, in the columns, you can, I already show you how like some of these. So this is super easy because I've already done that before. You can just call it a column. It will give you a series. But if let's say I want to only know the type 1 of a Pokemon, and I don't care about other things, and I just want to like slice this bit, like slice this bit. Oh, I can't do this. Like slice these two columns. So what I can do is that. Yeah, I wish you can see. I think you can see my cursor here, right? So I only want this two thing. So yeah. So what I can do is that if I, put in a list of the column name within that square bracket, which is get item thing, and you would get a new data frame with just those columns. You can actually like also maybe you want to look at the generation as well. You can also put the generation there. Oops. So it doesn't matter. It doesn't matter whether they are consecutive or not. So it will still grab it for you. Imagine like it's just like tell me which column you want and you put it like this. You can also reorder them if you want to. So and you can reorder them like this. So now you will have an idea. I have this idea. I don't know whether it's in your mind. That what if I want to sort this table according, arrange the column according to the column name. You can do that. So remember, should I put it in? Let's put it in a different, a cell. That so I can keep this normal thing, and I got to do my experiment here. Okay, remember that this one dot columns will give you the column, and you can change it into list, right? Oop. And this will become a list, and you can actually sort the list. So and dot sort, I believe, and it should be ascending or descending. I can't remember. Let's try this first. Yeah, to see if I can sort this column. Oh, it's not printing it out. Print it out for me, please. Print it out for me. Okay. Oh, it's none because, oh, okay, sorry about that. So, okay, it's slightly more complicated. So I call this um, Pokemon call. Okay, this is a column now, and I do a sorting because sorting is changing it internally and it doesn't return a new thing for me. So this is how it's gonna be. Okay, right. So now print. I would maybe create a new one. Okay, all right. Let's print this out to see if it's in alphabetical order. Okay. Do, do, do. Yes, it's in alphabetical order. So what if I put this back in our data frame? So pocket mon df, and remember this square bracket inside is a list. Is it a list? Yes, it's a list, So yes, we will have a rearranged data frame by doing this trick. So this is how you sort your table. And I found this very, very cool. Because you can actually, you can actually sort the data frame, the rows. You can sort it however you like. You can maybe sort it according to the attack, ascending, descending. So you can do that. I would maybe talk about that next episode. But for the columns, well, how to do that? Like you may be like scratching your head, then well, this is one way of doing it, and I show you a little trick. I hope it's useful. If not, just have a good laugh. And okay, so this is this is the slicing and dicing, and the index. You can also do something like that. For the index, remember we have all these. So okay, what I can do is like remember 711 is crazy. I want to see everything that is 711. Can I do that? Okay. This is a super duplicated thing. So let me see if I can have a look at this super duplicated, hit mon df, show me all this 711. Let's see if I can do that. Oh, I can't do that because it's not it's not the column name. So I want to do it with the index. So what I gotta do is to, let me think. Maybe I can do it like this. I can't really remember this one very well, so sorry about that. I think, okay, it's a 711 and then this. No, okay, and spice. No, it's invalid key. So okay, this one. I think I got it. Yes, I got it. Sorry, I've tried. I'm a bit rusty. Like I said, I'm not a data scientist anymore, but I still use quite a lot of pandas because I'm developing the Python client and try to get it to work with pandas. Okay, so yeah, so this is how you call do this slice here. So what it is doing here is that log is a method for the pandas data frame object, and it will take two arguments. Actually, it's called a slice. If you don't know what is all these like slicing things, watch Naomi's tutorial last Friday on Twitch. It's still there. Go watch it. I will put the link. I think she uploaded it somewhere as well. You can find it on her Twitter as well. I will try to find it and put the link in the description. I always said that and I forgot. If I forgot, ask me on Twitter. I would put it, would find it for you. Okay. So yeah, so this is a thing I call slice. So 711 comma colon. So what is this? So this one, the first thing in the slice, this one is actually saying the index bit here. So give me all these index at 711. Remember, this is not a very ordered index. It's a crazy index. And, and then we give me all of them. And you can see that these are all these are all the same Pokemon. It's just like average, small, what? You have like it come with different sizes. It's like buying a fish from the market. I don't know, or eggs, and this is a colon means that you just give me everything. Okay, give me everything. I only want the slice for the index. So you can also you can put in a name here. So just give me the name. I don't care about other stuff. So it would just give you the name, and because it would convert into a column, so you can actually like name and the type, please. We can do it like this. Type 1, I believe. So don't miss that. Yeah. So this will give you data frame back. So because this one works just like what you do with the column, so the only difference is this. So we have already talked about log, kind of. There's another method that always got messed up with log is called ilog. So let's talk about ilog. So let me grab this because I'm so lazy of typing and put it here. So this time, what I can do is I can keep 711. Let's see what happened. Okay, and for this one, I would give it a 01. Okay. Okay, so this is interesting. Now I got a series back. I only got this thing. What? Okay, let's go one step back. So give me everything, but this. So instead of multiple 711 here before, so this time 711 is only one thing. So you can see this is actually a row of this Pokemon, right? And it's actually number 711 in our data frame. So can you spot the difference here? The difference is ilog actually only check in numbers. So if I put name and type 1 here, it will give me an error, okay? So first hint, it's only checking a number. So it doesn't work this way, okay? You could put colon, which means everything, or if you just want the name, you put in the 0 here. Actually, I don't want the bracket because it's, so it only give you one thing. So ilog will treat this data frame as if it's just all this bunch of array, a two-dimensional array. So it just took all the values. Oh, by the way, I haven't talked about values. Sorry about that. Let's secretly go back to our internals, because there's this thing called values, which I totally forgot to talk about until now. So let's go to V. So yeah, values here. So let's try this out. So let me add a cell below it and do the Pokemon. I don't know why I use Pokemon. It's like so difficult to spell and values. So yeah, it's inside Pandas data frame. Actually, it's a two-dimensional array that store all your values. Okay, so the ilog will actually treat your data frame as this array, and if you want to do a slice of it, you have to give an absolute integers to the rows and the columns. So it could be, this is 0, 0, this 49 here. Oh, actually I swap it, right? So yeah, I swap the order of this. So this one is just a showcase, of swapping it, but you haven't assigned it back to Pokemon DF, so Pokemon DF is still this one. Okay. So just to be clear, let me print the Pokemon DF here again. So, or maybe I shouldn't do. Yeah, let me print this again so we are not confused. Okay, let's print this again here. Oh, I have so much to tidy up work to do here now. Okay, so the 0, 0 actually it will be the Bulbasaur here. This is, because this is row 0, because like everything starts with 0, row 0, and column 0. So this is Bulbasaur. This will be 0, 1, 0, 2, etc., etc. This is 1, 0, etc., etc. So this is how ilogs work, okay? So the I makes such a huge difference here, and yeah, so people who don't actually understand would encounter problem or like why ilog and log will give me such a big result. Even you can even if you put in if your index it's both numbers, right? 711. It's so different because it's referring to different things. This one is the absolute 711, so you count it from like 0, 1, 2, 3 until 711, and you got this. But this one is just like, oh, which one is the label as 711 in your index, okay? So this is something that is small, but people overlook and people make mistake, and then like, oh, I see. So yeah, and I hope this help you to understand a little bit better. And I'm lucky that I have this like messy index that actually I didn't plan for it. I only realized that, and that it's really useful to demonstrate things. So this is slicing and dicing and a little bit of columns and everything. And anything you'd want to know, let me know in the chat. I would, just talk about it. I'm so free flow, but we have 7 minutes left. Let's go through change data types, okay? So let's look at this. And so go back to D types. I did show you before a little bit of that, but we changed the data type when we read the data. So now, okay, we have already read the data. I realized that I have to change the type. Do I have to read it again? No, you don't have to. You can just change it as is. So let's look at the DF, the D types of the data frames. So D types. Remember the S. I always forget, and remember no bracket. Okay. So yeah, in case you are not sure, you can do the dir, or you can actually, I think you can, or look it up on the documentation. That's the easiest, I think. So yeah, we have this, and now let's say I change my mind. I want this generation to be integer again. So what should I do? So let's look at documentation. and our best friend documentation. Okay. So yeah, it's S type. That's the most common one you could use. You have a lot of other choices when you deal with a series. S type also work for series, uh, but but for series you have much more options to do as well. So yeah, there are a lot of ways to do it. I think I'll cover S type first because it's the most generic one. You could use it to cover most cases. Um, so yeah, okay. Yeah, you can see all these like two something something that's like also you could use that as well. So look at how to do this because I can't remember that well. Okay. Oh no. Okay. Yes. So what you can do is that you do a yeah, you can put in you can put in a dictionary to change it. So this is just like what we did before when we read the data frame. So let's do this. Let's do this. Okay. So I changed my mind. I want to change this generation back to an integer, please. So, well, it's very simple. You just do as type, and this is exactly what we did before. We have a dictionary. We are mapping the column name to the data type. So I want to make the generation into, this time I want to make it back to int 64. Okay. And okay. Oh, one thing. Let's have a look. So you have this copy thing. So okay, pandas. A lot of things in pandas actually is changing it inside a data frame. It would change the object inside, like the series inside. It would change, you know, yeah. So how can I say it? Like, so it won't make a copy of the data frame for you. Some people found it frustrating because but because like why like you don't make a copy and then people accidentally change the data frame without knowing that it will do the changes inside. But I think there's some reason for that because um when you have a lot of data in your Jupyter Notebook, you don't want to make a copy every time you do an operation. That would really like blow up your RAM very quickly, and you don't want to do that. So a lot of the pandas operation actually is changing it won't create a new object. So your, let's say our Pokemon DF will be changed. So for lots of operation, you do it this way. But for some of them, actually it won't. So like when we shuffle the column names, it won't because well we're just we're just using the get item, the square bracket, and giving a new a data frame back. So that one is a new one. So I think a lot of time as a new user, the smart things to do is to always check the documentation, check whether it would change the object itself or it will create a new copy, right? Most of the time, the operation will have an option for you to do that, to switch it on or off. And the default, so what you want to do is that you want to check the default whether it will make a copy or whether it will not. So for this case, as type, it will the default is true. So luckily this time it will give us a copy. But if you set it to false, then yeah, it will propagate to other objects. So it will change the object itself. And because like I said, a panda data frame actually inside a lot of series, and it's a lot of stuff that is referencing some other object. So if you change the object itself, it would change all the things that reference to it. So be very careful because data frame is such a complex object. So it's always helpful to check what's going on, what's inside. So that's why I talk about the internal. Again, I talk about internal because I want you to know that each of these things, each of these columns, index, and values inside, and a series of these actually are objects that pandas may refer internally. So um, sometimes changing one of them, it would change make some accidental changes, and that's why it's like useful to be careful about like how you do the operation and what result you will get. Okay, so this time is fine because we will get a new copy. So yeah, let's try that. So there's not much here, but if you see that, if yeah, so it doesn't change because, like I said, it makes a copy. So if do I want to no, I don't want to assign it to a because like I want to keep the thing. So I would just check it here. So this will give me a new object. Okay, so that's why it's not saved here. And I want to check the d type of this new object, and it will become an integer. Okay. So let me delete this. This is not needed. So yeah. So be very, very careful of your operation. We haven't go into those dangerous one yet, I think. But yeah, every time you mess with the operations, check your documentation. That's why it's handy to have your documentation. Check your documentation, whether it will return a copy or not. So we may encounter more next time when we do other operations that is more complex. Then you would kind of you know that you have to be careful when you use pandas. And so back to changing the data type. So there's one way to do it, as type is the most generic way, but sometimes I have a string, and this string, I don't know much about it. I don't know whether it should be changed to an integer or a float, because I don't know whether there is a decimal inside. It's just a string for me. So what you could do is like you can use a to numeric, and so it would try to change, automatically change it into numeric format for you without you worrying about whether I should use an int. Is int 64 enough, or should I use int 32 to save space? If I do, neural network training, then maybe 32 will save you a lot of space, and is actually you can benefit of it. Or you handle a lot of data, a 32. Sorry, yeah, 32 is better than a 64. But if 32 is not enough, you have to use 64. So when to use which? So yeah, to numeric will deal with it for you. Automatically. So for example, this one is see the dots here, and then it will become a float automatically. Okay, and you can also have other things to control it. You can control what happened to an error. You can ignore and let it be, or make it into a NA, NaN, not a number. And also casting it, you can downcast it. You can try to, can't you save space for me, please? And then the float will become a so we try to squeeze it down to save memory for you. So yeah, by the way, this like all these age, 60, 64, 32 is like how many bytes a computer used to store one of these. So how many bytes to 8 bytes to store an integer, 8 bytes to store an unsigned integer, then you actually save a byte as well, because 1 byte is used for the assign. One bit, not yeah, 1 bit, not byte, sorry, 1 bit to store signs. This one unsigned is saving 1 bit as well. And yeah, and float, and it's so it's either 32 is a decimal number, whether I use 32 bytes to store it or 64 bytes. So of course, smaller the smaller, I won't say smaller the better, but smaller the safer, the more memory saver. I don't know how to say. Yeah, the smaller the memory saver. Is that a phase? Okay. Yeah, anyway, so yeah, if you want to save memory, you want to have lower numbers. So downcast will help you to do that. So you could, you can actually tell it to be like, come on, squeeze it. Like, I don't care about the accuracy. Squeeze it to float 32 for me, please. So you can do that. And so to numeric, it could be useful as well. And what else? To daytime. Whoa, okay, daytime is a nasty thing. Um, and I love daytime, yay! And so yeah, daytime. Actually, this will call a daytime parser to try to change it to a daytime format for you. So yeah, so we will try to read it, in this format. But if you have something that is not a date, month, year, it could be month, date, year, like the American do. Then you could actually, put in your format. When you change to daytime, then you could customize the format here. And you have other options, UTC, and like yes, sometimes just like, oh, I know this person will put the year first, and it's easier for the parser to know, because the parser know that it's years first, year first, right? So yeah, so this is some like how you change it into daytime. It will give you a daytimed object actually. So type depending on the input. So yeah, if you put in a list, then it will become a datetime index. If you put in a series, it will become a list. The type will be datetime 64. So you can also change the timestamp as well. So yeah, you can actually apply this to your data frame, and then just change. Usually, you'll just pick out one series and do it like this. Change it to datetime 64, or you can use S type like here. S type. You can just like, oh, please change it to datetime 64, and it will do similar operations to do that. Um, yeah, and ooh, there's so many things. Time delta as well. So this is like how. So for example, we use like 1 day, 2 days difference, or 1 hour, 2 hours difference. Then you would get a time delta object, and this lets you to do that, to change it. So it's like 1 day, so we'll change it into a time delta object. Oh my God, daytime is a topic deserve itself. I may come back to this in the future. Just talk about daytime thing, because yeah, and interval as well. And if you combine them, you have daytime interval. Yeah, don't want to deal with it at the moment. So yeah, this is like I think yes, an hour and a half, and this is just the very very basic of pandas. I may actually come back to this and readjust this, because we only touching like the surface, and we have more to do, and I think that there are more that we could talk about. So maybe I could split this into two tutorial. So there's like a lot of things that we got to cover. So maybe we need to spend 3 episodes to talk about pandas, because it's so huge. And in between now and next week, let me know what you want to know, what you want to learn, and any comment about this. Is this too fast? Is this too detailed? Is it too short? And let me know in give you can message me on Twitter. You can either tag me publicly, or you can, if you want to privately message me, this is also fine. In my Twitch that you're watching now, down there's a ask a question box. You can put comments there as well. If you're watching it like, because like usually after 24 hours I will upload this on YouTube, but usually I will share a link to my um, so anyway, if you're watching it on YouTube for the catch up, then leave it in the comment. I would also try to check it. So far I haven't checked it that often, because there's actually quite a lot of spam on on YouTube, but usually they got removed quite quickly. But still, I got some message like, oh, someone commented. I'll check, and then it's some advertisement comment, I would say. So yeah, so Bosch, if you comment, I will still also try to check, and I know that you're a genuine person, because I can tell I'm not that like whether you're a bot or a person. So I think I'm quite smart to see, and so okay, let me go to the ending slides here. Oh, again, this these things. I know it's super messy right now. I'll try to add in some comments, and it won't be as detailed as this video, but I will add in some comments to know, at least what I'm trying to do here, and I will upload it in my GitHub repo. And yeah, so this is a new series, so a lot of things are still a bit rough. So let me know what I can improve, what can make you learn more, and just let me know. And next week, just more pandas. We're gonna continue to talk about pandas, and I hope 1 hour and a half is good. Usually I try to aim for 1 hour, but if it's topic like this, super complicated, something that I like, it could go to 1 hour and a half. Apologize if you're busy, but you can always watch my videos afterwards. It will be available on Twitch 14 days after, today. And also afterwards, after 24 hours, I'll upload it on YouTube. They could be found on my personal webpage, check.dev, cheuk.dev. You can find all my previous recording there, my other Python tutorials there, and my other like something about about Terminus DB, the database I'm working on as well. It's a graph database. If you're interested in data, you may want to check it out. And yeah, and I don't know what to add. I should actually stop talking. I'm just too excited. And really hope to see you next week. And if you have the time, Monday, like every Monday, 5 p.m., I will recommend you to come join me in the chat and tell me and ask me questions, and help me out if I forgot the name of something. And yeah, so thank you so much for watching, and I will see you Actually, on Wednesday, if you want to watch Meet Me Pi, that I chat with Lace, my friend, about Python, and we have our special guest this week is David from Flask. So if you are interested in Flask, you may want to watch the interview. And I'll see you on Wednesday or next week, whenever you want to watch me online. So see ya.